Okay, left off. Should be starting up page 819, elevator rescue. All right, elevators. Classified based on the primary use. We got passenger elevators, typically small, accelerate quickly, automatic controls. We have freight elevators, slower, larger access doors. Construction elevators, those are similar to freight elevators. Elevators operating systems either use cables or hydraulics. Let's talk about a cable system first. Used in structures of any size, know that any size, consists of a fully enclosed elevator shaft, elevator car, counterweights, safety brakes. I'm not going to read all of them. An observation elevator, variation of a cable elevator mounted on the wall of an atrium on the exterior wall of a structure. That's where passengers, you get the scenic views with that particular elevator. And a hydraulic elevator. You need to know that they have a ram piston beneath the car that raises and lowers it. They have hydraulic oil that provides the necessary pressure. And you also definitely need to know that it's used in structures less than 6 stories tall. The mechanical room containing the power unit is usually located on the lower level of the building, within 100 feet of the elevator shaft. Some hydraulic systems also have cables counterweights used in cable systems. If the elevators become inoperative, and that could be a list of things right here, earthquakes, explosions, loss of electrical hydraulic power, jam, broken cables, short circuit. There is no consistent sequential steps to follow for elevator entrapment rescue. Now, what that's meaning is that there are multiple ways that you can go about whenever you get called out for an elevator rescue. Now, first of all, I'm gonna back up on something real quick. When we're talking about the cable electrical systems versus hydraulic systems, during your pre-incident planning, it's important when you go out to these structures to know where is their control room located. In that control room is going to be your breakers for the elevators, and you're also going to have a control board, a control panel. Now, so let's say you get called out for an elevator rescue, and if it's a electrical elevator cable system, more than likely the control room is going to be on the roof or somewhere up high. And if it's a hydraulic system, then the more than likely the control rooms are going to be on one of the lower levels, maybe on the first floor or ground floor, something of that nature. Now, 9 times out of 10, we go to an elevator rescue. What I have found that it's a very simple process to actually get the elevator moving again. More than likely, it's gotten stuck. I haven't ran into too many problems where there's any medical problems or medical issues with the victim. So first thing, if you can make contact with the victim and then find the control room, go into the control room. Now, if you'll notice if it's got 1 elevator, 2 elevators are usually marked, number 1, number 2. So have your radios with you, have somebody else talking to the victims, which car are they in, and a lot of times you can open up the panel and you'll see a control panel. Now, some of these control panels have a little reset button, and you can actually reset that panel, and then the elevator will start operating properly. If you can't find a reset button, then you can shut the system down, shut off the breaker, 5-10 seconds, turn it back on, and that'll reset the panel. That's one way that you can do it, and it's probably the easiest way. You're not damaging anything. It's quicker. Another way you can do it would be on the elevator doors. You'll see a little notch or a little hole in the top of the doors, and we have these particular keys. We can slide these keys in that little elevator slot, open up the doors. But the problem with that is if you're going to go and start opening doors, then a lot of times you're going to go kill the power to it. So you're already shutting off power, so you might as well shut it off for a few seconds, turn it back on, and see if the panel will reset. Now, let's say the panel did not reset. So now you can actually take the key, slide the door open, and see where the patient might be or the people might be. Uh, Another way you can do this is actually try to find out from the owner of the occupancy, find out if whoever they use to repair their elevators, if they can call somebody in and maybe they're close by. And if they can get there within 30 minutes or so, then they can come in and reset everything and get the elevator operating correctly. The last thing you want to do is take any sort of forcible entry tools and start prying the doors open because you will damage them and now they're going to have to replace those doors. But if it was a situation, it's a medical emergency, the technician is several hours away, you've tried resetting and actually shutting off power, didn't work, then you may have to go to your forcible entry tools. So it's just saying there's no consistent uh, sequential steps that are actually going to determine how you're going to basically operate on an elevator rescue. So, but assess the situation, determine the task, and choose your best options for safe, effective rescue. So, thought I'd throw that out there to you. And different captains, different stations are going to approach this differently. They will call out the rescue for every elevator rescue. I will tend to cancel the rescue until I get on scene because a lot of times I can fix the situation, and that means they don't have to drive all the way out to another location for that problem. Sometimes just assuring the entrapped occupants while waiting for trained personnel from the elevator company may be the best, safest option. It can often be more beneficial to have the occupants wait for the elevator personnel to arrive on scene if there's no medical emergency. You can also, their elevator phones, they can actually dial 911 on the phones located in the elevator. That dispatcher who receives the call may decide if the call goes to an elevator company or emergency services. It's usually going to call the emergency services. It's just saying entrapped occupants can also use their cell phones to call 911. All right, as a firefighter 2, is intended to function in a support role to train technicians in an elevator rescue. So the technicians may be better qualified firefighters, members of a technical rescue crew, or representatives of the faculty or elevator service company. Now, as you gain experience out there in the field, you're going to come up with a way that you're going to feel comfortable doing this. And if you don't feel comfortable resetting a panel, shutting things off, then wait until the rescue company shows up. Upon entering the building for an entrapment call, contact should be attempted with the occupants. Maybe by phone or in a machine room or a mechanical room. Otherwise, shout through the hoistway at the nearest landing. Attempt can be made to recall the elevator to the main floor and open the doors. There's one other way that you can actually try to recall the elevator, and it's using the key that is on the first floor. There's a little special key. It's usually marked fire department key, and you can actually use that key, and that will recall the elevators to the first floor. But you'd either have to go to the Knox box, it's either in the Knox box, or the front desk or someone else might have it. Maintenance might have it. Rescue practices at elevator entrapments usually center around gaining access to the elevator car through the hoistway door. After making communications with the occupants, firefighters should disconnect power to the elevator. So that's something you need to know. Disconnect power to the elevator. Once the power is disconnected, there are methods for accessing and opening the hoistway doors. So location of the elevator between the building, ability to recall the elevator, type of elevator system, estimated time of arrival of a repair contractor. Hoistway doors can be opened using hoistway keys, something I mentioned earlier, on-site machine room, in a specific elevator key box. So depends on, usually not all engines carry those keys, but there are some engines that actually have those elevator keys. So if you have to call out, let's just say engine 14, has a set of those keys and you need them, then you have to give a dispatch, see if engine 14 can meet you over at the structure so you can use their keys. Once the hoistway doors are open, evacuation procedures can proceed. First step, aligning the elevator doors to the open hoistway door. Elevator may need to be moved closer to the open hoistway door. That might involve turning power back on, closing the hoistway doors. Once the elevator is closed to the landing and the power's been turned off, occupants can step up or down to come out. Assist the occupants if necessary. Evacuation should be quick. Never position an occupant or rescuer halfway in or out of the elevator, as the elevator could suddenly descend, trapping or killing anyone that might be inside. So remember, if the power is on, there's possibility. So if you are going to be moving people in and out, and the elevator is actually in between the floors, you're going to have to do it fairly quickly and as safely as possible. If the situation is urgent, rescuers can access the elevator through the escape hatch. You can lower a small ladder into the car. Crews can remove the occupants through the escape hatch. Rescue personnel or occupant could fall down an adjacent shaft, so be careful if you are doing this particular type of rescue. Passing elevators or counterweights could strike personnel or occupants, because there's a lot of parts that are going to be in that shaft right there, so just make sure you do things safely. Make sure the power is off at the main disconnect. Engage the stop switch on the elevator before gaining access to the top of it. Before leaving the elevator, disconnect should be in the off position until the elevator personnel arrive. All right, escalator rescue. So just remember, going back to that lockout tagout. If you are going to kill power, use the lockout tagout system. Elevator rescue, escalators, or escalator rescue, also called, know this, moving stairways. They are chain-driven mechanical stairways that move continuously in one direction. The steps are linked together. Each step rides on a track. Each escalator in a structure is an individual installation. The drive unit is usually located under the upper landing. Variation, moving walkway, sidewalk, similar to a conveyor belt, something that you would find in, say, airports. That's where I've seen them mostly. They do have manual stop switches. We need to know where these are at. On many escalators, you need to know, located on a nearby wall or handrail, support at the top and bottom of the unit. And activating the switch slowly stops the stairs, sets the emergency brake. There is a key-operated switch that's located in a covered compartment at the bottom of the escalator that restarts the escalator after the stop button has been activated. The stairs should be stopped during rescue. Extrication operations involving moving walkways or sidewalks are similar to escalators. Most escalator rescues result from victims' fingers or toes caught between the step treads. To extricate a victim, remove other passengers, use hand pressure to move the treads backwards. Move the treads backwards, know that. Some escalators have hand cranks or wheels that move the treads backwards. After extrication, the elevator is placed out of service until a technician can work on it. Electrical line emergencies. Electrical line emergencies, some jurisdictions, incidents involving electricity are not considered technical rescue situations. Rescues involving energized power lines or equipment. Some of the most common and dangerous situations to which firefighters are called. Improper actions can injure or kill you instantly. Okay, whenever you respond to any situation involving electricity, you need to know this. Assume electrical lines and equipment are energized. Know that. Establish a scene security and deny unauthorized entry. Know that. Direct bystanders to shelter in place. Call for the electric company to respond. Know that. Stand by until the electric company arrives. Allow only electric company personnel to cut electrical wires. Vehicle striking a power post, severing a high voltage line that falls on the vehicle. First, communicate to the trapped victims that they should remain in the car. Know that. Next, contact the electrical company to shut off the power. Once that is done, the incident becomes a vehicle extrication incident. Electrified subway and train tracks, that's going to pose a hazard for firefighters. Passengers may fall onto or between the rails. Firefighters may have to enter tunnels to assist these passengers from the stalled trains or subway cars. Never work around these tracks unless the power has been shut off. Okay, before we get into rescue tools, I'm going to go over something. It's an acronym. Failure. Write this down. FAILURE, acronym. Now I'm going to tell you what this is for. Basically, if your rescue didn't go the way that you wanted it to, it basically failed, this might be some of the reasons why it failed. Let me get to this page. Okay, so the F. F stands for failure to understand the rescue environment. The A, additional medical implications were not considered. The I, inadequate rescue skills. The L, lack of teamwork. The U, underestimating logistical needs. The R, rescue recovery not considered. And the E, equipment not mastered. So those are some things you need to know. Remember failure. All right, rescue tools. Rescue tools based on two criteria. They're either going to be power source or use. Power source, manual or power operated. And we need to know this. We need to know it may be used for stabilizing, ensuring that a vehicle or structural member will not move during the rescue. Cutting, removing materials or debris to free a victim. Lifting, raising a vehicle component or structural member off a victim. Raising the victim out of a space. Pulling, pulling is dragging away materials to free a victim, and other activities, securing materials in place, breaking up materials to free a victim. Okay, you need to know all of those. Power sources. You need to know these three. There's three main types, but know all four. Power source for power operated tools. Electric, hydraulic, pneumatic. Pneumatic means air operated. And a combination of electric and hydraulic. Make sure you know that. Tools from different manufacturers have different capabilities. Know that. Power saw from one manufacturer produces may not be able to perform the task that a saw from another manufacturer cannot. Hydraulic extrication tools may not be unable to perform tasks that pneumatic extrication tools can. So just know, right tool for the right job, and that different manufacturers, different capabilities. All right, electric. Know this, power can be provided by rechargeable batteries. Know that. It can also be charged by an apparatus electrical system or a portable vehicle-mounted generator. Not all of our apparatuses actually have the capability to power tools. Older units that we have, they have a separate generator on those older engine companies. Those you can plug into and power some power operated tools or lights if you need to power the lights. All of our new engine companies, they have an inverter. They do not have a generator anymore, and you're not able to power tools anymore off of our engine companies. So if it's a newer engine company, you're probably going to have to, if you need to power something, the only ones carrying the generators are truck companies. So you'd have to either wait for Truck 4 or one of the latter companies. They could actually power lights and some tools off of that. But most of our power operated tools that you carry on engine companies are going to be rechargeable batteries. Now, Rescue 3 carries a variety of tools, and they can also power their tools. So it's a little bit different. Electricity's main advantage, availability at the scene. Electric tools are lightweight. Battery-powered tools, more portable than tools with cords. Can run out of power and stop working suddenly without any indication. Extra batteries should be available. Always follow manufacturer's recommendations, keeping them fully charged and dispose of them properly. Several electric-powered rescue systems are available. More portable than other varieties, power compatible to hydraulic tools. And that leads us into hydraulic tools. So, what we need to know about hydraulic. Hydraulic is fluid. It is a fluid. We need to know that they provide operating power in the form of hydraulic pressure to most powered rescue tools. Most of our powered rescue tools are hydraulic fluid. May be operated in several ways. Handheld, electric motor, battery, or gasoline engine. So just know that these are hydraulic pumps pushing the fluid, and they can be handheld, electric motor, battery, gasoline engine. Need to know that. May be portable and carried with the tool or mounted on the vehicle and connected through a hose reel. Rescue 3 mounted on the vehicle, connected to hose reels. They also have battery hydraulic tools that are very nice. Most everybody else that carries these actually have the gasoline engine. Inspect the pumps regularly. Hoses and connections, make sure they don't leak. Connections are clean and work properly. Leave maintenance to qualified personnel. Always leave maintenance to qualified personnel. Now you can check the gas, you can check the oil, you can check the spark plug, but if you need to replace and repair, qualified personnel only. Pneumatic, air. Pneumatic is air. Power to pneumatic tool can be provided by pressurized air from, and you need to know, compressed air cylinders, a vehicle-mounted cascade system, or portable or vehicle-mounted air compressors. If SCBA cylinders are used to supply the tools and adequately, the quality of cylinders must be on hand to meet the tool's demand for air. So what it's saying is, you can actually use the SCBA bottles for pneumatic tools. Now, you remember whenever we're filling up the bottles in the cascade system, if I have a 2200 bottle, you'll notice that I go to the regulator. You guys are now going to the regulator, and you're setting your regulator at 2200 psi. Well, a lot of these tools may only work off 125 or 120 psi. So what you would have to do on your bottle, because it's 4500, 2200 psi, is you would have to have a regulator on your SCBA bottle. And you would have to be able to set that for, say, 120 psi, just like you do whenever you're filling bottles at the cascade system. So same concept. Pneumatic rescue tools are used for lifting, pushing, pulling, hammering, chiseling, cutting. Lightweight and more portable than electric and hydraulic tools, but they are slower. Know that, slower, and they are less powerful, more labor intensive. Most vehicle repair tools are adapted for use in the fire service. Some of the examples of Porta-Power brand tools come along. Accessories enable tools to be used for many purposes. Always follow manufacturer's recommendations. Let me check my time. Let's do stabilizing tools real quick. Page 826, stabilizing tools. Know this. Before a rescue or extrication operation can begin, you must ensure that the scene is stabilized. Know that. Vehicle, object, structural component, or trench wall must not be able to move. This can injure the victim and or a rescuer. All right, stabilization tools include, we're going to go over these, jacks, a tension buttress system, wheel chocks, and cribbing. So you need to know these tools. We'll start off with jacks. Jacks can be used for lifting, should always be placed on a flat, level surface. Know that if a jack must be positioned on a soft surface, place a solid base of cribbing or a flat board or steel bearing plate under the jack to prevent it from sinking in the surface. Know that. A hydraulic jack. Okay, a hydraulic jack. Know this. It is designed for heavy lifting. Know that. When used in conjunction with cribbing, they can be used for stabilization. A non-hydraulic jack, less powerful than hydraulic jacks. You need to know the difference in these non-hydraulic jacks. You will see this again. A screw jack. A screw jack is extended or retracted by turning the threaded shaft. Know that. You need to know the two common types, a bar screw jack and a trench screw jack. Both have male thread stems and a female threaded component. All right, a bar screw jack. You need to know that that is used to support collapsed structural members. Know that. They are heavy duty, primarily used to hold objects in place. The shaft is turned with a long bar that is inserted through a hole in the top of the shaft. A thread screw jack often replaced wood cross braces during trench rescue. They are durable, inexpensive, and easy to use. So know the difference in those two screw jacks. A ratchet lever jack. You need to know that a ratchet lever jack is also known as a high lift jack. It is medium duty, primarily to stabilize and lift, can be modified for use in pushing or pulling during vehicle extrication. This is something that's important too. Least stable of all jacks. It is the least stable of all jacks. If their load shifts, the ratchet lever jack can fall over, allowing the load to suddenly drop on its original position. Prone to fail under heavy loads. Here's the key to this. When we do any sort of extrication, always try to stay on your feet. Do not get on your knees to try to work on stuff. You want to be able to move if something goes wrong. Remember failure. Consists of a rigid I-beam with perforations along the side and a jacking carriage that fits around the I-beam. So the most important thing is that first part that I told you about on the ratchet lever jacks. A tension buttress system. Tension buttress system. You need to know that this stabilizes vehicles resting on their sides or roofs. They consist of one or more posts wedged between the ground and the vehicle. Number of posts needed and their placement is determined by the condition and the weight of the vehicle, the stability of the soil, and the conditions of the victims. Systems provide a larger area of stability for the vehicle and prevents it from moving or tipping over during extrication. Wheel chocks. You need to know that wheel chocks prevent vehicles from moving when they are parked. When placed against a downhill side of the rear tire, they can hold a vehicle in place. They can be used to stabilize vehicles in any accident. They can be constructed of aluminum, hard rubber, wood, or polyurethane plastic. You need to know that. They typically have a pad or traction cleat on the bottom. They can have handles, ropes, or grab holds to make them easier to carry. We do need to know that these materials, we need to know that stabilizes vehicles during extrication or debris following a structural collapse. Or that's cribbing. Hang on. There's something we got to add to this. Oh, here we are. I've missed this part. They are designed, wheel chocks, designed to resist corrosion from oils, fuels, and solvents. Make sure you know that. Now let's go to cribbing materials. Got a little ahead of myself. Cribbing materials. All right, need to know this first part. Cribbing materials. Stabilizes a vehicle during extrication or debris following structural collapse. They consist of wooden or plastic blocks or wedges in a variety of lengths and widths. The block ends may be painted with different colors indicating the different lengths. Flat surfaces of cribbing should not be painted or finished because paint or finishing can hide defects, cause the surfaces to be slippery when wet. Individual blocks may have rope or webbing stapled to the end so that they are easily carried. Wooden cribbing, the blocks may be locally constructed, commercially purchased. Plastic cribbing, often preferred because, know this, it's preferred because it is lighter and lasts many times longer. You do need to know that it resists contamination of fuel, oil, or other substance, but it may slip under wet conditions. It is stronger than wood but may fail without warning. More expensive to replace than wood. So make sure you know that about the plastic cribbing. The last part is I want to add, before we take a little break here, is cribbing. Remember these words. Box formation. Box formation whenever you hear cribbing, because you're going to build it in a box formation. Crib as you lift. So as you lift something, you're cribbing. All right, let's take a little break.